Good morning, students. Today we will discuss another topic of theory of machine, that is motion of follower. So mainly the motion of follower can have any of the following motions. Like it can move through uniform velocity, that is the first case. It can move through simple harmonic motion, that is the second case. And it can also move through uniform acceleration and retardation, that is the third case. So we will discuss today two of its motion, that is first one is uniform velocity and simple harmonic motion. So let's get back to the first one, that is uniform velocity. So this is the velocity diagram or motion of follower according to uniform velocity. There are three graphs, one A, B and C, which I have given here. That A represents the displacement diagram, B represents the velocity diagram, and C represents the acceleration diagram. So before starting into the graphs, let us first know what are these axes denoting. So along on these all three graphs, the x-axis, that is abscissa, denotes the time, which time, the time to cover one revolution of cam. That means the time to be taken for the cam to complete one complete revolution. And along the y-axis or ordinate, we have taken in displacement diagram displacement, in velocity diagram velocity, and in acceleration diagram acceleration. So starting from the displacement diagram first, that there are four cases: rise, dual, return, dual. So rise and return are the cases when the follower are moving, and we will get back to dual. What is that? So first case is uniform velocity. As we all know that when an object moves with a uniform velocity, that means its displacement is constant. Simple meaning, we have gone through our basics that when object is moving with an velocity, or rather you can say in uniform velocity, then its displacement must be constant. So during the rise, that is denoted by AB1, and during the return, that is CD1, the graph should be constant, or rather the graph should be a straight line. That's why the graph AB1 and C1D is represented as a straight line or a constant slope. So these are the two denotion. That means the first case here I am going to say you that the first one, that is AB1 line and C1D line has constant slope due to uniform velocity. Since when there is a case of uniform velocity, then at that time the displacement should be constant. But if you go by B1 C1, or rather you can say BC and DE, let us consider the last point as DE. So if you consider B1 C1 and DE, it is simply showing a straight line. So in this time the follower comes to rest. That means this is indirectly denoted as a dual period. So we can say in the time of dual, the followers remains at rest. That means the follower moves only while in the rise period or in the time of return period. Otherwise, in the dual time or dual case, the follower remains at rest. So I am accumulatively once again the whole displacement graph, that is the rise and return has a constant slope. This is due to having uniform velocity and having constant displacement, and BC and DE has a constant line along the displacement time. This is due to at this phase of time the follower remains at rest. I hope you understand displacement graph. Now coming back to the velocity diagram. So while considering the velocity diagram, we get to know that as the velocity is uniform, that means the velocity will be a straight line. So we are just adhering these lines and connecting it to the axis, that is to the x-axis. So since it has an uniform velocity, so during its rise period AB1, it will be a constant velocity, that is denoted by this figure, and during its return period, it will in a decreasing velocity, but the velocity will be constant. So again it is denoted in the negative y direction, but it is again constant. So this indirectly shows the constant or uniform velocity diagram. Now coming back to the third one, that is acceleration diagram. So here you see that I have denoted all phases as a infinite. It is being shown as infinite because the at the starting and at the end of each stroke there should be a maximum velocity within no phase of time. So if it won't be infinite, then the velocity won't be maximum. So this due to this reason, these graphs is shown as infinite. So I'm repeating once again why this is shown as infinite. This is shown as infinite because if the velocity will not get back to its maximum velocity, then the uniform velocity will not reach to its peak point. So due to this, the acceleration is denoted as infinite during each stroke, at the starting of each stroke and also at the end of each stroke. So at the starting, at the end, at the starting, at the end of each stroke. But practically this case is not possible. The acceleration diagram will not be practically possible because at each case it won't be possible that the acceleration will be infinite. So I hope you understand. Nonetheless, I am repeating once again, that is the uniform velocity diagram indirectly shows that fourth period, that one is rise, dual, return and dual. Since it is a case of uniform velocity, so during a B1 period, the velocity will be uniform and the displacement will be constant, so it will have a constant slope. So a B1 representing a constant slope. Again during the return period, during C D1, it will again have a uniform velocity and a constant slope. So again C1D has a constant slope. But in the case of B, C and D2 maximum point, let us suppose that is E, it is a constant line. So it is a straight line. It is due to the fact that at this phase of time the follower remains constant. So during AB1 the follower is AB1 follower is moving, during C1D the follower is moving, but during BC or B1 C1 or D2 maximum point the follower remains at rest. If we get back to the second graph, then it is a case of uniform velocity, so that's why the velocity will be uniform, that will be constant. It is represented by a constant line. As it is a rise case, so it is taken as positive y-axis, and at the second time it is a return case, that means it will have a negative velocity but it will also have the constant velocity. And the third case, it is shown as infinite due to the fact that it will have to gain a maximum velocity with no phase of time. That will, it will not gain so much time. So with no phase of time, it will have to gain maximum velocity. It will be only possible when the acceleration will be infinite at the starting of each stroke and at the end of each stroke. I hope you understand the motion of follower due to the case of uniform velocity. Now coming back to the second topic, that is the motion of follower due to SHM. So before starting this one, you have to make few dimensions. That in the previous step we simply plot a graph. In the y-axis we have taken displacement, in the x-axis we have taken time. Again velocity time, again acceleration time. In the same case we have to take one different arrangement, that is, so while considering the first case, we have to make a geometrical arrangement, that is, you have to consider a semicircle at the end, left end, or at the starting end of the stroke during the displacement time graph. So we have made a semicircle and we have plotted a numbers, that is 1, 2, 3, 4, 5, 6, 7, 8. So this is not the case. You have to put 8 slots only. You can take any number of slots, but what number of slots you have taken at the semicircle, you have to plot that number of slots in the axis dimensions, both along at the starting end and at the end. So we have represented, that is theta 0 and theta r. So theta 0, that means at the starting stroke, and theta r means at the return stroke. This is the initial stroke, that is when the cam is moving in the forward direction, and this is the return stroke, that is when the cam is rotating in the time of returning direction. So this is So while considering the displacement time graph, we have seen a phase that during the initial stroke, while the forward motion of the cam, it is a constant slope continuously increasing, and at the dual time, that is when it reaches the maximum displacement that is represented by S. It is the case where it reaches the maximum displacement, and for a certain phase of time it has constant displacement, and this phase of time is known as dual time in this case of follower of motion. So, and again after reaching its maximum value of displacement, it again come back to its minimum value, and at the end it reaches to zero. That means during return stroke it reaches to zero by from maximum to minimum value. But we see that during the forward motion it takes more time comparison to the return stroke. So that's why here the graph or the flotation of the graph is taken as more curvilinear compared to this one. So the initial phase is the forward stroke, and this is the case of return stroke. Now coming back to the velocity diagram, since it is a case of simple harmonic motion, so we have to consider the velocity diagram as a sine curve and the acceleration time graph as a cosine curve. So you all know that what is the main difference between sine and cosine curve. That is, in the sine curve the curve will pass through the origin, and in the cosine curve it will never pass through the origin. So due to this the fact, it has drawn from this point, it has reaches to its maximum value, that is V0. It is the maximum velocity during its forward stroke, and it again reaches to zero. That means it is starting from zero, reaches to maximum value at the mid frame, again reaches to zero at the end of the stroke. Again during the return time it is starting from zero, it is reaching its maximum value towards negative direction, that is represented by VR, and again it is coming back to zero. So through velocity diagram we can assume that during the starting of the stroke it has zero, at the mid frame it is reaching to its maximum value, again at the end of stroke it is reaches to zero. Again if we go by the acceleration time graph, so we can see that it is taken as cosine curve, so that's why it is not crossing through the origin. So in the cosine curve or in the acceleration time graph, we have taken that at the starting of the stroke it has maximum value, at the mid frame it is reaches to zero, and the end of the stroke it is again reaches to its maximum value, that is represented by A0 during forward stroke, and during the return stroke it is taken as AR. So again starting of the stroke it is maximum value, at the mid frame it is becoming zero, and the end of the stroke it is again reaching its maximum value. So difference between uniform velocity, that is the case, and here the SHM is that in that case we have simply putting the uniform velocity. That means we have simply putting a graph which is constant or which is providing a constant slope, but here that is not the actual case. So during SHM in the displacement time graph, during the forward it will go a forward curvilinear path with constant slope, and again it reaches to maximum value, again it will follow a constant slope in a curved path to reach its minimum value or to reach its initial path by return stroke. During its velocity time graph it will start from zero value, mid frame it will reaches its maximum value, again it will reaches to zero at the end of the stroke. During the acceleration time graph it will start from maximum value, at the mid frame it will become zero, and at the end of the stroke it will again reaches to its maximum value. Now I will give you some formulas of velocity and acceleration. Please write it down also. So these are the main formulas which we get through SHM. That is the VO or AO denotes during the out stroke, that is forward stroke, and VR AR represents during the return stroke. So the velocity will be during out stroke will be pi omega s by 2 theta naught. There where pi is a constant value which will take as 22/7 or 3.14. Omega will be angular velocity of cam. It will be taken in radian per second, and s will be stroke of the follower, and theta naught will be displacement during out stroke, or rather you can say angular displacement during out stroke. Similarly, the acceleration will be pi square omega square s by 2 theta naught ka square. So write down these formulas, and remember it will actuated by the SHM, it will help you in solving numericals. During the return stroke, or it will also help you in dimensioning the cam. While designing a cam, these formulas will work. So now come back to during the return stroke, VR will be pi omega square into 2 theta r, AR will be pi square omega square by 2 theta. Similar to the both, just replace theta naught by theta r. Otherwise, all the formulas are same. So write down these formulas also. I hope you understand both the cases, that is motion of follower due to uniform velocity and motion of follower due to SHM. Okay, thank you.